Hello learners, this is Habiba with Excel with me. If you like the video, please do like, share, subscribe and comment below. Let's start today's class, that is research and education. Techniques of sampling, that is probability and non-probability sampling. In the previous class we have understood about the population and universe, population or universe and sample. What is population actually? When we do the research, we need some subjects. The all category of all the subjects includes in a population. From among the population, we tend to take a few sample as our subjects for our research study. So here what we understand a sample, the method of selecting a representative subset of the population, that is they are representing the whole number of populations, a subset of that whole number of population, that is we are selecting them. That makes research more accurate and economical. If we try to take whole population, it's not possible to do the research accurately. So we have to select some sample to make our research accurate and perfect. So a sample should be the representative of the whole population, obviously. Now let's see the example again here. To study newspaper reading habits among the school students, not possible to include all the students in the study. So what we do, need to draw a sample of the whole population, that is all the students of the school, that will become our population. If all school students are 500, then selected sample of the study would be 100 to trace the newspaper reading habit. To do our research, to make it average number, what we will do, we take 100 students from among the whole population size of 500 students. Now sampling, the process of choosing a sample of the population to study is called sampling. That is, so many types are there of sampling. That's why whatever the type we choose, the process we choose, that from the population, that is called sampling. Now let's see the techniques of sampling. There are mainly two types of techniques, that is probability sampling and non-probability sampling. Today we are going to understand in detail about probability sampling. In the next class we will understand the non-probability sampling. Let's start with just meaning of these two. What is probability sampling? It uses random sampling technique. We will understand what is random technique also in the next slide. That is, probability means equal chance. That means whoever subjects we are going to take, they have the equal chance of getting selected. Non-probability, exactly opposite to that, that is it involves judgment. There won't be any randomization. Randomly we will not pick. It uses non-randomized methods. So let's understand in detail about the probability sampling. A representative sample of the whole population, as we understood. Let's see through one example here. There are 500 students in a school, same thing I have taken previously, that is 500 students are there. They have the equal chance to be the participant in the study, that is called probability sampling. Now probability sampling, there are 5 main methods. They are simple random sampling, systematic random sampling, stratified random sampling, cluster sampling, multi-stage systematic sampling. Let's understand all these sampling methods in detail. First one, simple random sampling, that is each element and each combination of elements in the population have an equal probability of being selected as a part of the sample. That is, there is no judgment or just picking up. Here fair chance, fair way to select a sample, that is best known probability sampling. That is, so many, you can see the picture here, from out of this whole population we select randomly one from one group, another from one group, another, that is simple, randomly we are selecting that sample. That is technique. So let's see how we select them. That is techniques of using simple random sampling, tossing a coin. For example, we take a coin and toss it, whoever takes the head or tails, that type we select that sample. That is throwing a dice, maybe lottery method. We take all the 500 students' chits and randomly we pick up one ticket from among them. That is lottery method. Blindfolded method, you close your eyes, a whole lot of list will be there and you point out one list or something, then you can pick that. Two ways of conducting random sampling, with and without replacement. Let's understand what is that. In case a certain element is selected and has a chance to be selected again after the required variables are measured is called sampling with replacement. That is, certain elements, how they will be elected, they have the chance of getting selected again after the required variable. That is replacement. On the other hand, opposite to it, in random sampling without replacement method, that is, an element once obtained cannot be selected again. Once selected means selected again, no replacement of that. That is no replacement. Then random sampling requires a sampling frame, that is a list of all the elements in the population. Obviously, when you have all the elements of the population, then only you can pick randomly from among them. Let's see the example. The same example here, you will understand much better if I take the same example. If I take different examples, then it will become hard to understand. So here the same example, newspaper reading habits of students, of school students. That school has maintained a computerized record of all the students correctly enrolled. That is a sampling frame. When you have whole data in front of you, whoever are enrolled as having the habit of newspaper, all the students, sorry, not habit, all the students. Suppose we need a sample of 100 students from this enrollment list. We have several options to draw the sample as mentioned above. I told you, tossing the coin maybe, or blindfolded, or lottery system, dice system. However you want, you can take that technique. Then second one, systematic random sampling, an improvement over the simple random sampling that requires the complete information about the population. It is the improvement over the previous which I explained, that is simple random sampling, that is select one unit from the sampling frame and then calculations to draw following units and done on the basis of the interval size. A very easy method, one of the most widely used sampling method. Here let's see, that is choose every 9th participant from a complete list. Here I have given the example of every third person. Nth person I have taken as third. Every third person, maybe every fourth, every fifth, like that you can take easily out of whole population your sample size systematically. Then the third one is stratified random sampling, that is an improvement over systematic sampling. The population elements are divided into strata on the basis of some characteristics, that is from each of these smaller homogeneous groups draws at random a predetermined number of units, that is how many number you want predetermined, you from that unit you can take as your population. That means whole population is there, all men, all women, all children. I have divided into units, that is strata. I made some strata, so this is called strata. From among them I can choose how many in number I want, how many men I want, how many women I want, how many children I want. Maybe from that children also, boys and girls, can be divided those units. I can take as stratified random sampling. Stratified random sampling can be of two types, that is proportionate and disproportionate. That is proportionate stratified sampling means when the size of the sample is proportionate to the unit. Whatever unit you have picked up from the whole population, that will be proportionate. Same number again you will not pick from the sample size from that unit. Now disproportionate means, stratified sampling means when it is not proportionate to the size of the unit. From among the population you choose the unit, and again from the unit you take how many number you want, that many subjects you can take from that unit. Now, disproportionate stratified sampling depends upon considerations involving personal judgment and convenience. How convenient you feel and judge yourself by yourself, then you can take that subject as along. Now, let's see the example. Divide the administration of the school into two subgroups, that is teaching and non-teaching staff. To ensure adequate representation of each stratum, that is subgroup, the sample is then drawn from each stratum or subgroup randomly or systematically. That's your choice. Then strata are divided keeping in mind that there must be heterogeneity between the strata and homogeneity within the stratum, that is heterogeneity between the subgroups, that is teaching and non-teaching, but among the group of teachers it should be homogeneity, and among the teaching staff that is homogeneity, then only it will be perfect. In the case of stratified sampling, there is an increase in the accuracy of the result if each stratum is more homogeneous within and heterogeneous between each other, that is teachers, teaching staff. You cannot mix teachers along with some management or any administrative staff, any other administration working. You cannot mix up. Teachers means only teachers. Then non-teaching staff means only non-teaching staffs. These could be heterogeneous, but from among the teaching staff it cannot be heterogeneous. Only teachers, homogeneous group it should be. Then it will be accurate. The results will be accurate. Now, the fourth one is cluster sampling, one of the efficient methods of random sampling. The population is first divided into clusters and then a sample is selected from the clusters randomly. Mostly feasible method in case of diverse population spread over different areas. Not possible in case of simple random sampling. The participants with different demographics are selected randomly from these areas. That means I will give you one example here. Let's see, it is also economical method and saves the time of researcher. To study the average women's height in India, it is not possible to get a list of everyone. So, in such case what we will do, divide the areas into clusters, maybe north zone, south zone, east zone, west zone, northeast, northwest. How many zones we want, we can make them a cluster, draw a sample randomly from those clusters. So, that is the best example of here your population of all customers, for example, we have taken. So, we make one customer buying one different product and then other different product, same wise cluster 1, cluster 2, cluster 3, cluster 4, that is whichever we want we take from those clusters. So, this is called cluster sampling. Now, the fifth one is multi-stage systematic sampling, that is use a combination of various techniques. The population is divided into groups again at various levels, a group within a group within a group and so on it can be. The sample is finally drawn from the smallest group among all the groups. Let's see the example here. First, country, that means whole number of population we can see. Then different, in our country we have different states. Then first stage dividing into states, and then second stage will be districts. So many districts in each state, so we divide them into districts. Then households, how many households are there, we can take as a third stage. Then individuals, that is fourth stage. Then final sample is drawn from all these groups. Again, one more example here, step by step this multi-stage sampling. Let's see here, population, suppose 25 districts we have taken as whole population. Then from among them we take 10 districts, that is 884 secondary schools, that will become first stage. Then we will divide this into boys and girls. What is the second stage? Dividing them into boys and girls. 60% from each district and 60% from each district, boys and girls. Then the third stage, male heads, female heads. 75% from each district, 75 from each district, females. Then we take the total sample here. At the end, it will become 402 secondary school heads we will take from among them. So this is the multi-stage sampling technique. We come to the end of this session. We will continue this non-probability technique in the next class. If you like the video, please do like, share, subscribe and comment below. Thanks for your attention and time. Happy learning.